Hello again. We are continuing our discussion of derivatives of very specific functions, and today I'm going to talk about the derivative of the inverse of the exponential function, which is the logarithmic function ln x. Some people say ln x, some people say ln x. I'll try and use both equally, but the derivative of that function is 1 over x, and I will prove that on the next slide. And of course, the chain rule, the product rule, and the quotient rule still apply. So if I have a function that is the natural log of x to the fifth plus 4x to the third plus the natural log of x to the fourth plus 7 plus x squared times the natural log of x, I need to find the derivative of that. So that is going to be, for the first part, I'm going to put that entire set of parentheses in the denominator followed by the derivative of it. That's chain rule. So it's going to be 1 over x to the fifth plus 4x to the third times the derivative of that, which is 5x to the fourth plus 12x squared. Then for the natural log of x to the fourth plus 7, it's going to be 1 over all of that times the derivative of all of that, which is 4x to the third. And then for the last one, I have to use product rule because it is x squared, which is a function, times the natural log of x, which is a function. So that will be 2x times the natural log of x plus x squared over x, or x squared times 1 over x. And if I simplify that, I get 5x to the fourth plus 12x squared over x to the fifth plus 4x to the third plus 4x to the third over x to the fourth plus 7 plus 2 times x times the natural log of x plus just x. All right, so remember, those rules still apply, even though we're talking about new functions. So here's how I'm going to prove that the derivative of the natural log of x is 1 over x. Okay, if I have a function and it's y equals the natural log of x, that means that x is e to the y, because e and natural log are inverses of each other. All right, so now instead of finding dy dx, I'm going to find dx dy. Well, the derivative of e to the y is e to the y. We talked about that in the last lesson. So now if I want to find dy dx, I flip it upside down. So instead of it being e to the y, it's now 1 over e to the y. And since e to the y is equal to x, the derivative is 1 over just x. All right, so that's proof that the derivative of the natural log is 1 over x. All right, if you have any questions, please let me know, and I will see you tomorrow.